Right, we'll start inshallah with acids, bases, and salts. Uh, this is the topic actually. So we'll start with acids first. Acids. When we talk about acids, basically, what are acids? A substance that produces which produces hydrogen ions, H positive ions, when dissolved in water. Or you can also say that acids are substances that give H positive ions in an aqueous solution. All right, they give off, they give H positive ions in an aqueous solution. Right. So what does that really mean? What does this giving of H positive ion really means? If you look at an example of hydrochloric acid, aqueous. All right. Or let's say there's a difference between HCl aqueous and HCl solid, which is most of the times in the powdered form. It's in the powdered form. This is hydrogen chloride. All right. And HCl aqueous is hydrochloric acid. All right. So if you have hydrogen chloride, let's say solid, and if you're going to put that in water, let's say H2O, it's going to become HCl aqueous. Now, what does HCl aqueous actually means? This actually means that hydrogen and chlorine have dissociated into their respective ions. This is what aqueous actually means. You understand? We need to understand what aqueous means here. Aqueous means something that has dissociated in water, that has dissolved in water. Let's take another example. If you have NaCl solid, right? And if you put that in water, what do you see? You get NaCl aqueous. What does that mean? It means there is water, but it means that the Na and Cl have dissociated into their ions. That is why you cannot see them anymore. And there is water also, which you can see. Aqueous and aqueous. This is what it actually means. This is what this statement means. You understand this point? So when something dissolves in water, means it means that it has dissociated in water. Right? When something dissolves in water, it means it has dissociated in water. It is dissolved in water. Is this making sense to you? Similarly, if like hydrogen chloride, HCl, this might be in solid form, HCl. All right. When you're going to put that in water, this is going to be looking like this. HCl, HCl, Cl, Cl, they have dissociated, and then there are water molecules around. You get it? Is it making sense? So now they are moving around. These particles are moving around, going here and there. just like the particles of liquid, which was not the case before. That is why, if you could recall, ionic compounds, when they were solid, like in the case of sodium, when they were solid, they cannot conduct electricity. But once they are in aqueous form, they can conduct electricity. Why? Because their particles can easily roam around now. They've dissociated. And once you're going to evaporate the water, they are going to, if you are going to dehydrate them, they're going to become solid again. You get it? Like pieces of block again, the powdered form again. So this is what dissociation means. This is what takes place when you put a substance that dissociates in water and gives off H positive ions. You see, the H positive ions were not for use before. They could not have been used before. Now they have dissociated and they're moving around separately, separated from chlorine. This is what dissociation actually means, which we would have to learn a lot when we are talking about solutions and electrolysis, inshallah. So this is what it is. Acids, substances that can dissociate in water and give off H positive ions are called acids. We need to know that acids are substances that dissociate to release or give H positive ions in aqueous solution, right? This is what they are, acids. We need to know that acids are covalent compounds, but they have properties like ionic compounds. You understand? Something becomes acid only when it is in aqueous form. So acids acids are always aqueous. You get it?
Yeah.
What else do we need to know about acids? We say that acids, there are two types of acids. We have not gone into the properties, chemical and physical properties yet. We're just discussing acids at the moment in general. Acids are of two types: mineral acids and organic acids. Mineral acids and organic acids. Mineral acids are the acids that do not have carbon hydrogen as their backbone or as the main elements of the compound. For this, we need to understand what are organic compounds. In biology, we have already discussed that. I'll just give you a glimpse of it. Or just a reminder, organic compounds that have carbon and hydrogen as their main components. Like what? Like glucose, C6H12O6. The main components are carbon and hydrogen. CH4, C2H5, so on and so forth. Or ethanoic acid, which is vinegar, CH3COOH. You see, this is an acid, but ethanoic acid. But most of the elements in these compounds, in organic compounds, are carbon and hydrogen backbones. And in mineral acids, it's not the case. So mineral acids generally are the ones such as uh, starting from the most strongest of all, hydrochloric acid, HCl, acid, and then sulfuric acid, H2SO4, right? Then we have nitric acid, which is HNO3, right? And then these are the few. Phosphoric acid as well, H2PO3, and all of those. Carbonic acid as well, H2 carbonic acid, H2PO4, sulfuric acid, so on and so forth. These are the acids that generally we found that are mineral, which is called mineral acids or inorganic acids, or you can say inorganic acids. Organic acids, which are also, these are considered as strong acids. Mineral acids are very strong acids. Organic acids are generally weak acids. Weak acids, they are considered as weak. We'll discuss about what does this mean, weak and strong. This is another distinction of acids. Like mineral and organic, this is another types of the two types of acids. All right. So generally we have um, citric acid, ethanoic acid, and acids like that. All right. All the carboxylic acids. Like methanoic acid, ethanoic acid, butanoic acid, and all of those. We'll study about them. Now, this brings to us a thing. This brings us to an important distinction of strong acids and weak acids. Strong acids. Strong acids are ones or acids that can fully dissociate in an aqueous solution, right? What does fully dissociate means? Fully dissociate means to give all the H positive ion, or to dissociate all the H positive ion. All the H positive ions, they get dissociated. All right. Like sulfuric acid, H2SO4, if you're going, it dissociates into two H positive ions plus SO sulfate ion. You get it? HCl, it dissociates fully. It dissociates fully into H plus Cl negative ion. Dissociation takes place like that. Aqueous, aqueous. You understand?
Yeah.
So they're strong acids. They're giving a lot of H positive ion. More H positive ion, more H positive ions, stronger the acid, less the pH, right? Lower pH, like between 2 and 3, 1, 2, and 3, right? You understand this? Strong
Yeah.
acid, weak acid. This H positive ion actually is responsible for the acidic property? Do you understand now? This H positive ion is actually responsible for acidic property. Is this clear? It is, they are only acids when they are able to dissociate. They are not acids if they cannot dissociate. They are not acids. Like even strong acids cannot dissociate in organic solvents, right? Even strong acids can't dissociate in organic solvents like ethanol.
Mm-hmm.
All right. We have two type of solvents, right? Organic and inorganic solvent. Inorganic or universal solvent is water. There are other organic solvents like lipids. There are some of the lipids. There ethanol and all of that. Alcohols. These are called organic solvents. So they are not able to dissociate. So they do not have their acidic property over there. Do you understand? They do not behave
Mm-hmm.
as acids over there. Even the strongest of acids they do not behave as acids in alcohol because they cannot dissociate over there. It should be pure, but if there is a little amount of water over there, they are going to dissociate. All right.
Mm-hmm.
Do you understand?
Yeah.
Association is the key. They need to be in an aqueous form to be an acid. Acid cannot be an acid if it is solid. Do you understand? So this is, let's say these are not acids if they are solid. If they are solid, they are not acids. They are only acids when they have dissociated in aqueous form. Is that clear? Similarly, let's talk about weak acids. When we talk about weak acids are ones that don't dissociate fully. Fully, right? They still they still retain one of the, they still retain the the hydrogen ions, right? Give you an example of weak acid. Like, let's talk about mm, let's talk about ethanoic acid. CH3 COOH. Right? If there are two of them, let's say, if there are two of them, one of them might dissociate. You can get N-spotted wine. The other one might not dissociate, so it's going to stay like that. Let's say this is dissociated, so it's like this. And you understand the result?
Yes.
One of them have dissociated and the other one didn't. So there were two molecules of ethanoic acid, right? One of them has dissociated, the other one wouldn't have, didn't. That, to understand this easy, you can also understand this by like this. Even though this dissociates fully, but if it would not have, if it would have been a weak acid, it would have dissociated like this. You get it? Not fully
Yep.
dissociated. This is called partial dissociation. Called partial dissociation, which is they get partially dissolved. So they are only able to provide 50% or a very less number of hydrogen ions that they could have. Or sometimes, most of the times, this is a reversible reaction. So what is happening? If certain number of this is if certain number of them have dissociated, similarly at the same time that number also associates back. All right, do you get it? Most of the time this is a reversible reaction like this.
Mm-hmm.
What does this reaction means is that once 50% have converted, the rest of the 50% from here are going to turn back. Do you get it? So there is always going to be only a half H positive ion dissociation, not the full. Because once the 50%, like that, in total there are 100%, right? In the beginning they were 100. So 50 of them stayed like this, and 50 of them stayed like that. So what does that mean? It means that 50%, only 50% of this is being produced. Do you understand this?
Yeah.
Alhamdulillah. So this is what a weak acid is all about. This is actually how you are going. This is actually how you're going to be seeing examples about weak acids. Not generally like this. All right, because we do not we consider that we whenever we are talking about the dissociation, we always try to consider one molecule only. All right, so in order to explain one molecule it is difficult. So you need to understand this by a reversible reaction, which is the real reaction. This generally is not a what generally it takes place. This is what generally takes place. It is always a weak acids always have a reversible reaction. Strong acids always have a forward reaction, irreversible reaction. Once they are converted into H positive ions, they are not going to reassociate anymore. Do you understand? If HCl has been placed in H2O water, it has become something like this. It's not going to go back, never going to reassociate. Do you understand? This is what we are trying to say. But a weak acid, half of them are going to reassociate, and only half of them will be left. Is this clear?
Yeah.
Alhamdulillah. Now let's talk about the properties. Properties of acids. There are certain physical properties. Then we are going to be discussing chemical properties. When we talk about physical properties, we say that acids have a sour taste, right? We say that the acids turn blue litmus blue litmus paper red, turns blue to red. All right, and they conduct electricity acids dissolve in water to form solutions that conduct electricity. Right? These are few of the physical properties that are there. Right? We're going to be talking about chemical properties. Actually, there are three reactions in general. We'll talk about them, inshallah. Is this clear? Are you writing them down, inshallah? Right. Let's move on to the chemical properties now. Actually, what we are going to be doing, we are going to be doing three reactions. Number one, acid plus metal reaction. Number two, acid plus base. They're going to be in general two of such reactions, two reactions in that. And the third one is going to be acid plus carbonates. These are the three reactions that we would have to study. All right. For the as chemical properties. I've written this just to create a mind map for you so that it is easily understood by you that what are the things that you could you are easily able to recall. All right. So
Mm-hmm.
all right. So uh, number one, let's talk about acids. Acids plus metal. So when acids react with metal, acids react with metals to give salt plus hydrogen gas. All right. General equation that is for them is metal. That is most all more 90%, 900% is going to be a solid. And then there is an acid which is always going to be aqueous. It's not an acid if it's not aqueous. And the result is going to be a salt plus hydrogen, which is always going to be a gas. And this salt can be aqueous and it could be solid depending upon its solubility. You understand?
Yeah.
All right. Almost all of the reactions are going to be like that. Let's take an example. Na plus HCl, solid, aqueous is going to give you NaCl, a chloride, which is aqueous, which is it means it is soluble, and a hydrogen gas. The observation for this reaction is going to be the observation. What is going to be the observation for this? Is going to be metal dissolves, disappears, disappears in a layman's term. In reality, what is happening? It is dissolving. What does that mean? It is being converted into ions. Ions being forming aqueous, becoming aqueous, right? And number two, bubble. Bubbles of hydrogen gas is going to be seen in the reaction. Something like this. This is the metal. Let's say this is the acid, and the bubbles are going to be bubbles. You're going to be seeing a lot of bubbles coming from the metal. All right. And
Mm-hmm.
there's a test for it. What is the test for? A pop test, right? A pop test. Squeaky pop sound is made if you bring a splinter, if you bring a glowing splinter, if you bring a glowing matchstick over it, lightened wood splint, if it is brought over it, it is going to create a squeaky pop sound. Right? This is the test. What you might observe over here is, if something, let's say magnesium reacts with sulfuric acid, it is going to give you a magnesium sulfate plus H2, right? It is always easy to make ionic compounds. Why? For ionic compounds, to make the formulas for ionic compounds, it is easy. You just need to know their charges and their oxidation states. So the superscript of this is going to become subscript of this. Superscript of this is going to become subscript of this. So this becomes Mg2SO4, 2 gets cancelled out. So it becomes MgSO4. Similarly, if you have sodium reacting with sulfuric acid, you are going to get sodium sulfate. How did I get to know the formula? The same way. These equations are not balanced. Obviously, you would have to balance them when you're writing them. Just to save time, we're not going into that detail of balancing them at the moment. This is aqueous soluble and this is gas, right? So sodium has 1 plus, sulfate has 2 negative and 4. So this is going to become Na2SO4, right? Something that is very important for you to understand over here, that is going to help you a lot when you're doing acids and bases, is that you will see that when metal reacts with sulfuric acid, you get sulfates, right? Like magnesium sulfate over here. When metals react with hydrochloric acid, you are going to get chlorides, like sodium chloride over here. You understand? Are you able to get this?
Yeah.
MgSO4, NaCl, or MgCl2. You get it? So these are the two things that you should have to, when they react with nitric acid, you're going to get nitrates. So sulfate ion is something like this, chloride ion looks something like this, and nitrate looks something like this. NH3 minus 1. All right. So you're going to get nitrate as sodium nitrate. Is this clear?
Yeah.
But there are some exceptions. Some exceptions. There are some exceptions. What are those? Unreactive metals. Metals such as copper or silver, Ag. They do not react with dilute acids. Don't react with dilute acids. All right. The unreactives. Generally, the ones that are below the hydrogen in the reactivity. We're going to see the reactivity series in a short while when we are doing is sodium, potassium, sodium, potassium, magnesium, zinc, iron. You're going to see that. All right. I'll just write it for you. I'll just write it for you. The reactivity series. Sorry, it was supposed to be potassium, sodium, calcium, magnesium, zinc, iron, lead, hydrogen, copper, and Ag. You see, the ones that are below, generally the rule of thumb is that uh, elements below hydrogen in reactivity series don't react with dilute acids. All right, is this clear?
Yeah.
Only concentrated nitric acids do react with, such as copper and silver, copper and Ag. They do react, only concentrated, but they do not give hydrogen, but don't give hydrogen gas. Instead, a nitrate salt with water and nitrogen dioxide. Instead, what do they give? Let's say HNO3 reacts with copper, it's going to give copper nitrate, the salt, plus nitrogen dioxide gas plus water. You know? Another exception is lead. Another reaction is lead. Lead, you have to, this is an exception from the reactivity series. Lead does not react with dilute hydrochloric acid and sulfuric acid. It does not. Why? Because of a layer, because of layer of PbCl2 or PbSO4 that is formed immediately from initially, right? Initially the reaction takes place. So some of the acid is converted into the salt. But once that salt is there, it forms a layer. This layer is insoluble in water, right? We'll see that some salts are insoluble, like lead. So this layer is insoluble in water. So the salt that is formed initially, like this is lead Pb plus HCl. It's going to form, most of it is going to remain Pb, but some of it becomes, there's a layer of PbCl that is formed. This PbCl is insoluble in water. So it does not react, forming a coating, forming a coat around metal. So if it is insoluble, it means it is not going to react any further. Do you understand? So does not, so Pb does not react any further. Is this clear?
Yeah.
Should we move further?
Give me 2 minutes. I need to finish
All right,
calculating
all right,
down.
all right. So further, this was the first reaction with acids, right? So in generally, what you need to know in acids when they react with metals, they are going to produce salts and water. Sorry, salt and hydrogen gas, right? Salt and hydrogen
Hmm.
gas with metal. The next reaction is with the second one is with the carbonates plus acids. So acids react with carbonates. Carbonates are ionic compounds that have carbonate with them, like N sodium carbonate or magnesium carbonate, right? Or potassium carbonate, like that. Zinc carbonate, like that. Acids react with carbonates to form a salt, carbon dioxide, and water. Right. The general equation is acids plus carbonates are going to give you a salt, water plus carbon dioxide. Like let's take sodium carbonate plus HCl aqueous. All carbonates are actually insoluble except sodium, potassium, ammonium carbonates. The three carbonates that are insoluble.
Hmm.
This one is actually going to be soluble. So when they react together, we can take the one which is in solid form, no problem. It reacts with water to give you NaCl, which is obviously aqueous, it is soluble, H2O, and carbon dioxide gas, liquid, right? Similarly, if you react magnesium carbonate with sulfuric acid, you're going to get magnesium sulfate, which is an aqueous plus. Well, let's take an example of an insoluble one. Lead carbonate gives you magnesium, gives you lead sulfate, which forms a PPT. Actually, it's solid. We're going to consider that solid, PPT formed, precipitate plus H2O plus carbon dioxide. Is that clear?
Yeah.
How to check the gas that is being produced is carbon dioxide? We are going to be checking this gas. We're going to be checking this with lime water test, right? We're going to take this test tube, into lime water. Lime water. This is the delivery tube. This is the delivery tube, and we have this metal over here. Let's say sodium carbonate. and acid, the gas that is going to be produced in this reaction is going to go there, and the lime water test. Water turns milky, right, to give a positive result. And why is that? Because there is a PPT precipitate that forms that makes it look milky and murky. All right. Is this clear?
Yes.
The third one is acids and bases. Even though this is a discussion that should be done later words, but still I'll just discuss here a little bit of it. Bases can be of two types. Bases are the ones that are soluble and the ones that are insoluble. The soluble bases are called alkalis, and insoluble bases are generally called bases. You get it? So basically, they are hydroxides, metal hydroxides, sodium hydroxide, or sodium oxide that actually can dissolve in water, right? And there are other insoluble bases, bases that do not generally do not dissolve in water. We'll write zinc oxide, let's say, solid, right? So this reaction, acids and bases, which include the bases and the alkalis, both of them, so include alkalis as well, react to give salt and water only. All right, salt and water only. You have to keep that in mind. React to give salt and water only. This reaction is also called neutralization reaction. This is called neutralization reaction.
Okay.
Right? Neutralization reaction. It's called
Mm-hmm.
neutralization reaction, something very important. All right. Whenever you are going to find acids or something that acts as an acid or base or something like acts as a base, if they react together, you're going to get salt and water only. All right. Salt and water only, and that is called neutralization reaction. Some of the examples like metal oxides, when we talk about metal oxides, zinc oxide, metal oxide plus acid is going to give you a salt plus water. Salt and water, right? Or metal hydroxides that are generally soluble alkalis, which are alkalis, and they react with acid, they give salt and water only. Examples could be, for the metal oxide, we can take zinc oxide, solid, plus dilute sulfuric acid, aqueous. We're going to get zinc sulfate plus H2. Right?
Okay.
Similarly, this is metal oxide, right?
Okay. So,
And for metal hydroxides, like this is called hydroxide ion basically, right?
mhm,
There's a negative charge. So let's take sodium hydroxide, which is a very common reaction. NaCl, aqueous, aqueous, aqueous is going to give you water which is liquid. Is this clear?
okay. Yeah.
So all metal oxides,
Can we finish off within 2 minutes?
and yeah, hydroxides, all metal
Mm-hmm.
oxides and hydroxides react with acids
Mm-hmm.
in the same way. All right. You can write this down. We'll do bases in the next session, inshallah. Right?
Okay. Okay.